Here we have a problem about a ball which is thrown vertically upwards, so it's traveling along a line, and its velocity, its initial velocity, is 64 feet per second. And I've changed this from distance traveled to distance from the original point, is given by s of t equals 64t minus 16t squared. And recall that this is the position function, and remember the velocity is the first derivative of this, and that of course is 64 minus 32t, and then the acceleration at time t is given by the derivative of the velocity, which of course is the second derivative of the position function, which is minus 32. And this is given in feet from the origin, so the unit of measurement here is feet. This is feet per second because it's a rate of change, and this is a rate of change of a rate of change, so it's feet per second per second. And part A asks, what is the velocity when t equals 1? Well, that's just going to be v of 1, and that's 64 minus 32 times 1, and that's 32 feet per second. And of course, because it's positive, the ball is going upwards at that point. When does the ball stop going upwards? Well, this happens when the ball turns, and when the ball turns, the velocity is 0. So if we solve this equation, v of t equals 0, then we should be able to find when the ball turns. So we see that the ball turns after 2 seconds. And the last question is, what's the maximum height reached by the ball? Well, of course, this is when the ball turns, it's reached its maximum height. It changes from going upwards to going downwards. That's the maximum height is achieved when v of t equals 0, and that is when t equals 2, and the maximum height then is equal to s of 2 which is 128 minus 64, which is just 64, and remember the unit of measurement there is feet. So we didn't need the acceleration in this problem, but it's useful to know how it relates to the position function.